Welcome to Finance with Fairbanks, where real-world finance comes to life. Remember to like this video and subscribe to the channel. Hello and welcome. My name is Dr. Fairbanks, and in this video we're going to work through return calculations. That is, we are going to learn how to calculate dollar returns, percentage returns, as well as return statistics. Let's go ahead and dive in. Last year, Josh purchased 350 shares of XYZ stock for $23 per share. Today, the stock paid a dividend of $1.10 per share, and he sold his shares for $25.75 each. Calculate the total dollar return, capital gain income, and dividend income earned on this particular investment. Our total return equation in this example, because we're looking at dollar returns, is simply going to be the number of shares that he owns times the following equation. P1, which is the price we sold it for, minus P0, the price we paid for it, plus div 1, or the income that was received on this particular investment. If we write that out, that would be 350 shares times the $25.75 that he sold each share for, minus the $23 that he paid per share, plus the $1.10 that he received from the dividends. If we do this in a calculator, we find that Josh earned a total dollar return of $1,347.50. Next up, we will calculate the capital gain in dollars, not percentage. And again, that's going to be shares times the price differential, or more specifically, the appreciation or depreciation in the price, or the price change. So we take the price we sold it for minus the price we paid for it. That is, we are going to take the 350 shares and simply multiply it by $25.75 minus $23. When we do this in the calculator, we find that he received in capital gain income $962.50. Now, to find the dividends, I could just take the total return minus the capital gain, but let's go ahead and just do the calculation. So the dividend income in dollars, again, is going to be the shares that he owns, the number of shares that he owns, times the dividend that he received, and that is $350 times $1.10, and it appears that he received $385 in dividend income. Last year, Lisa purchased a 5% coupon bond with a face value of $1,000, selling for 108% of par. Today, she sold that bond for 104% of par. Calculate her total dollar return, her capital gain income or loss, and her interest income. We're going to assume that Lisa purchased one bond, and we're also going to assume that the par value of that bond was $1,000. So that's the par amount that she purchased. Now, she could obviously purchase any number of bonds, but it wasn't specified, so that's what we will assume. The price that she paid is the 108% of that. So if we take 108% and multiply it by the par value, we see that she paid $1,080 to acquire that bond. She then sold it 1 year later at 104% of par value. That means that she sold it for $1,040. Her interest income, or her coupon income, was the 5% that the bond paid times its par value, or $50. So she received $50 in interest income. Her total dollar return, again, in this particular example, is going to be what she sold it for minus what she paid for it, plus the interest income that she earned. So in this example, she earned a positive $10 in total dollar returns. She does, in fact, have a capital loss. She did lose on this investment, and her capital loss is what she sold it for minus what she paid for it, and she lost, in fact, $40 on this investment. That's a negative $40. Her interest income, as we already saw, is a positive $50. So if we add 50 and subtract $40 from the capital loss, we do in fact get the $10 total return. Fair & Co. pays a constant dividend. Last year, the dividend yield was 6% when the stock was selling at $72.50 per share. If the current dividend yield is 5%, calculate the price per share on the stock. Well, what we have to remember is that our dividend yield is simply equal to the dividend that we will receive. In this case, they're constant, so I won't add a subscript, all divided by the price that we paid to acquire that investment. The first thing that I'm going to do is I'm going to rearrange this formula, and I'm going to solve for the dividend. So the dividend is equal to the dividend yield, which was 6%, times the price, which was $72.50. And when I do that in the calculator, I find that the dividend is $4.35. But what's happened over the course of this year is that the dividend yield has actually fallen. What that tells me in my mind is that means that the price of the stock goes up. But the question is, how much did the price of the stock go up? Again, rearranging the formula, this time I'm going to be solving for PV0. Well, PV0 is going to equal that $4.35 dividend, all divided by that dividend yield. So we'll take the $4.35, we'll divide that by 0.05 or multiply it by 20. That's another way to do that in your head. And we can see that the new price per share is $87. We are now transitioning into calculating percentage returns. Let's go ahead and look at the equation. So for percentage returns, we take total return percent. We can't ignore the number of shares outstanding now in this problem. And our numerator will be the price that we sold it for minus the price that we paid for it plus any income that was received, all divided by the price that we paid for it. Again, we saw this in an earlier example when we were dealing with the number of shares and the dollar returns, but let's go ahead and write this out. So we have 25.75 minus 23 plus $1.10, all divided by 23. We'll also go ahead and calculate his capital gain percentage. He did have a gain. The price did go up in this example. The mathematical formula for this is P1 minus P0 all over P0. Additionally, you can do this much more simply. Just take the price ratio P1, what you sold it for, divided by what you bought it for, and subtract 1. Mathematically, those two equations are the same. And then last but not least, we can find the dividend yield percent, and that's just div1 all divided by what we paid for it, P0. So if we do that one first, we know that we received, or he received, $1.10. He paid $23 at the onset of this investment, and that is a 4.7826% return. His capital gain would be the 2573 all divided by 23 minus 1, and his capital gain was 11.957%. We will confirm this in the calculator. Adding those two together or doing this mathematical equation, we should find that his total return is 16.739%. Let's go ahead and quickly confirm this in the calculator. All right, so we'll take the 1.1 divided by 23. We do in fact find that his dividend yield is 4.78%. 25.75 divided by 23 minus 1, and we do in fact find that his capital gain yield was 11.957%. And then last but not least, we can do the total return, 25.75 minus 23 plus $1.10, all divided by 23. And his overall total return percentage was 16.739%. Error here, so we'll go ahead and fix that. But yes, all of these were confirmed with the calculator. All right. Last year, Lisa purchased a 5% coupon bond with a face value of $1,000, selling for 108% of par. Today, she sold that bond for 104% of par. Calculate the total return percentage, capital gain yield, and current yield. Remember, we learned in the bond chapter that the current yield is simply the annual dollar coupon divided by the price. That's what we learned in the bond chapter. That translates here into our total return percentages. The number of bonds that she purchased is irrelevant. However, in the prior problem, when we were calculating dollar returns for this example, we just assumed that she purchased one bond. Again, we're going to use the same mathematical formula as the last problem. We will take P1 minus P0 plus her coupon income of $50 and divide that by what she paid for it. And we find that her total return is 0.926%. Her capital loss percentage, because that's what it is, it's not a gain. She paid $1,080. She sold it for $1,040, and she had a capital loss of 3.704%. Her current yield on this investment was the $50 in coupon income divided by the price she paid, $1,080. Her coupon income was 4.63%. Let's go ahead and confirm this with the financial calculator. Okay, so we'll do $1,040, that's the price she sold it for, minus the price she paid, $1,080, plus her coupon income of $50 or interest income, all divided by $1,080, and we do in fact find that her total return percentage was 0.926%. For the capital loss, we'll take the price she sold it for divided by the price she paid. We'll subtract 1, and we see that she has a capital loss of 3.704%. Last up, we'll take her coupon income or interest income and divide it by the price she paid, and that is the current yield on her bond investment of 4.63%. So we did in fact confirm all of these numbers on the slide, and they are correct. Last year, Cashton purchased 1,000 shares of Fair & Co. stock for $31,000. Today, he sold those shares for $33.5 or $33.50 per share. The dividend yield on the stock was 2.2%. Calculate the total return percentage on this investment. Well, the first thing that we need to do is we need to find the price that he paid at the onset of this investment. To do that, what we're going to do is we're going to take the value of the stock when he bought it, okay, so that's the value at time 0, divided by the number of shares that he acquired for that amount. That gives us a price per share of $31. The next thing that we're going to do is we're going to find the capital gain percentage. The capital gain percentage is the price he sold it for minus the price he paid for it, all divided by the price he paid for that investment. That comes out to 8.065%. Lastly, we will find the total return by taking the capital gain percentage that we just found and adding the dividend yield that was given to us in the problem. So we take the 8.065% and we add the 2.2% to it. We find his total return on this investment was 10.26%. Last year, Gwenny earned 7.8% on her investment, while U.S. Treasury bills yield 4.1%, and the inflation rate was 3.1%. Calculate her real rate of return on this investment. The one point I do want to make, even though it's not relevant to this question, is this. In all of these problems, it is assumed that the Treasury bill represents our risk-free asset, and so the yield on the Treasury bill represents our risk-free rate. Now in this question, we're going to use the exact Fisher equation to solve for the real rate in this problem. Okay, recall that if we rearrange that formula, the real rate of return is equal to the nominal rate of return divided by 1 plus the inflation rate minus 1. Again, that's 1 plus the nominal divided by 1 plus inflation minus 1. So in this problem, that's 1.078, all divided by 1.031 minus 1, and we find that Gwenny's real rate of return was 4.56%. We're looking at the exact same problem here, and that is last year Gwendolyn earned 7.8% on her investment, while T-bills yielded 4.1% and inflation was 3.1%. In this example, we want to calculate her nominal risk premium. Well, a risk premium is any return that is earned above the risk-free rate. Recall in the prior problem, I mentioned the fact that in finance, we assume that the U.S. Treasury bill yield is representative of, specifically the 1-month security, is representative of our risk-free rate. And so our nominal risk premium then just simply takes that nominal return and subtracts off that risk-free rate. So we take the 7.8% that she earned, we subtract off the 4.1% on U.S. Treasuries, and we find that her nominal risk premium is 3.7%. Historically, U.S. Treasury bills average 3.5% compared to long-term government bonds, which average 6.1%. Calculate the nominal risk premium. It's not really the approximate Fisher equation because Fisher wasn't calculating risk premiums, but what I mean by this statement in the question is that we're just simply going to take the nominal return minus the risk-free rate to find that nominal risk premium. That is, we're going to take the 6.1% that was earned on long-term government bonds, we're going to subtract off the 3.5% that was earned on Treasury bills, and we find that the nominal risk premium in long-term government bonds was 2.6%. Okay, we're now moving into return statistics, and because I know the subsequent problems that we are going to work on, essentially the next few slides, we're just going to do all of it here. So this one says calculate the arithmetic average, the geometric average. We'll go ahead and find the standard deviation as well as the variance, and we will find the dollar invested path or equivalent, is the way I like to call it, as well as the holding period return. Okay, so we're going to calculate all of this information here given these 5 returns. Now, we know from statistics that the arithmetic average return is simply the sum of the observations divided by n. So if I were to take the sum of these returns and divide by 5, I would in fact find the arithmetic average return. Then to find the variance, I would have to calculate what is known as the squared deviations from the mean. So I'd have to take this return value, subtract off the mean, and then square that value, and I'd have to sum that, then I would have to divide by n minus 1. But I got fantastic news for you. The news is that our financial calculator will find the arithmetic average, the standard deviation, and the variance for us in one fell swoop. Now, in order for us to find the geometric average return, as well as the dollar invested equivalent and HPR, we are going to need to calculate or create a new column on this table, and that is going to be 1 plus every single return. So the first one is 1.136, that's 1 plus the 13.6%. We get 1.052, followed by 1.104, 1.089, and then our last one is 0.969. That's again just 1 plus each one of those returns. Let's go ahead and go into the financial calculator, and we're going to learn about 2 new worksheets. And both of these worksheets appear from our numbers, which is a little different because we've been mainly dealing with the calculations and worksheets at the top of the calculator. These 2 worksheets are called the data worksheet as well as the statistics worksheet. Now, within the data worksheet, let's go ahead and go into that. So we'll just hit 2nd and 7. You're going to see that there are 2 possibilities. We get X's and Y's, and that's because this calculator can actually run a regression, which is beautiful. You just have to plug in your X values, plug in your Y values, and it will do that. We're not after that sophisticated of information here in this particular example. We're just trying to find some statistical measures. We're just trying to find the arithmetic average, the variance, and the standard deviation. Can we get that information from this? Absolutely. Now, what I'm going to do, just like with the cash flow worksheet, I'm going to clear it out. And as I enter these returns into the financial calculator, notice I'm not entering in the 1 plus the return column. I'm entering in the raw returns themselves. I have to make sure that I enter all of those values in as X values. Don't get that mixed up with any of the Y values. We don't have a second variable here. We only have one set of returns. That means, let's go ahead and plug these in. For X0, I'm going to type 0.136 and hit enter. I'm going to arrow down 2 times. That's skipping over my Y value because I don't have a Y value here. I'm going to type 0.052 and enter. I'm going to arrow down again 2 times. 0.104 and enter. Arrow down 2 times. 0.089 and enter. Arrow down 2 times. 0.031 negative and enter. Always double check, just like the cash flow worksheet, that everything has been stored in the calculator correctly. Now, that's great because what we've done is we've entered in these returns into our data worksheet. We're then going to hit the second key and the number 8. That's going to take us into our statistics worksheet. Now, there's more than one. Just make sure it says LIN. That's linear estimation. You can do all sorts of crazy things in this calculator well beyond the scope of this class. Okay, we're going to arrow down. That's the number of observations that you have. We do, in fact, have 5 X values. We're going to arrow down again. That number represents the arithmetic average return. So where you see that little X with a bar above it, that is our arithmetic average return. We're going to arrow down again. You're going to see a capital S of X. This represents the sample standard deviation. This is what we're going to want to use in our analysis. Now, while the calculator does give us the population standard deviation, we are never going to use this particular number, okay? Especially not with returns. You'll never know the true population. Now, to find the variance, recall, we have to take the square deviations from the mean, sum it, divide by n minus 1. But if the calculator gives us the standard deviation, we can find the variance because the variance is simply the standard deviation squared. So all I have to do is hit this x squared button. That is the variance for this particular problem. So we've already found 3 of the metrics that we need in this analysis. We need to find the arithmetic average, the standard deviation, the variance. Guess what? We did all of that. So let's just write it down. Our x bar, or arithmetic average, is equal to exactly 7%. Our sample standard deviation, S of x, we found this in the financial calculator, which was great. And that was 0.064027. Another way to say that, it's 6.4%, essentially. Ignore the sigma x because that's the population. So then to find the variance, we just square that number. And when we square that number, we find that the variance is 0.0041. So we have found 3 of the metrics that we need. And notice that those 3 metrics all focus on this column. Okay, I'm going to use a different colored pen now. And for this next series of questions, we're going to focus on the 1 plus the returns. I'm going to start with the geometric average return, and that's because the other 2 parts that we're after are all based off of that particular function. So recall, the geometric average return is simply the product of the 1 plus the returns raised to the 1 over n minus 1. That means that in this problem, we're going to take 1.136 times 1.052 times 1.104 times 1.089 times 0.969. Now there's 5 of them, so I'm going to raise that to the 1 over 5 minus 1. That is going to be the geometric average return in this problem. It has to be less than the arithmetic average, just like we talked about in class. But we also get some really cool information. As we're doing this particular calculation, the inside part of this mathematical equation for the geometric average, it represents what I call the dollar invested equivalent. Now, I really like this number because what it says is, had I invested $1 at the beginning of this asset's timeline, I would have this many dollars at the end of year 5. It's also scalable, which is really cool. So if I said, okay, well, here's my dollar invested equivalent, here's the number, and you say, well, I actually invested $25,000 at time 0, we would multiply it by that dollar invested equivalent, and that's what your balance would be at the end of year 5, which is really cool. Our HPR here is simply the dollar invested equivalent that we find through the product of the 1 plus the returns minus 1. That's it. And what that represents is your total 5-year holding period return, or however long your investment horizon is. But that tells you your total return that you earned over the entire investment horizon. So let's go ahead and do this in our financial calculator. We're going to take the 1 plus the returns, so we'll take 1.136, multiply it by 1.052, multiplied by 1.104, multiplied by 1.089, last but not least, multiplied by 0.969. The product of the 1 plus the returns, again, is representative of the dollar invested equivalent. And in this example, the dollar invested equivalent is $1.39. Again, that's pretty cool because I could say, well, I invested $20,000. I just multiply it by this number that we're seeing here in the calculator. That's what that investment would be worth at the end of year 5. Now, if we subtract 1 off of that number, we are now seeing a percentage, the holding period percentage, and what we say is that the entire 5-year investment horizon had a holding period return of 39.22%. Now, there's a reason why I'm not subtracting 1 here, and that's because I want to use this number to find the geometric average. So I'm now going to raise it to the 1 over 5. So I'm going to go open parentheses 1 divided by 5 and hit equals, and then I'm going to subtract 1. And I find that the geometric average return in this problem is 6.842%. Again, let's write all of this down. Our dollar invested equivalent was equal to $1.3922. Our holding period return percentage was equal to 39.22%, and our geometric average, which should be less than that 7%, came in at 6.842%. Now, the last thing that we want to do here with this data, we already know X bar, we know the average return, it was 7%, and we know the standard deviation was 6.4027%. We found that information, and now what we're going to do is we're going to find confidence intervals. Recall, if our returns are normally distributed, we can use the 68, 95, 99.7 rule. So the 68, 95, 99.7 rule says this, that all the returns in the 68% confidence interval must fall between plus or minus 1 standard deviation from the mean. Our 95% confidence interval says that it should fall somewhere between 2 standard deviations within the mean. And last but not least, the 99.7 says it should fall between plus and minus 3 standard deviations from the mean. Now, in this problem, we want to find the 95% probability range or confidence interval for the given information. What we're going to do is we're going to find the lower bound, and the lower bound is going to be the x bar minus 2 times s of x. So that's going to be 7% minus 2 times 6.4027. And what we find is that the lower bound on this particular series of returns is negative 5.805%. Our upper bound on a 95% confidence interval is going to be X bar plus 2 standard deviations. So we'll take the 7% plus 2 times the 6.4027. And what we will find is that the upper bound on this set of returns is 19.805%. Now, why do we care? That's a great question. That's because the 95% confidence interval range, that's what this is going to represent, is between negative 5.805% and 19.805%. What does that tell me? It tells me that if these returns do come from a normal distribution, that 95% of the annual returns should fall within this range that we found here, between negative 5.8 and a positive 19.8%. Last problem here, it says XYZ stock had the following returns: 13.8%, 8%, negative 7%, negative 2%, and 11% over the past 5 years. Calculate the probability that an investor in this stock will lose more than 12.755% in a given year. Now, without Excel and the ability to use normal distribution functions, this problem has to hit one of our confidence intervals. More specifically, it has to hit the lower bound on either the 68, 95, or 99.7 confidence interval. But in order for us to solve this, we are going to need the arithmetic average. We are also going to need to know the sample standard deviation. Now, rather than doing this by hand, because that would be painful, what we're going to do is plug these returns into the X values in our stats or data worksheet. So let's go to our data worksheet, clear it out. We'll enter in these new returns. So 0.13 and enter, arrow down 2 times, 0.08 and enter, arrow down 2 times, 0.07 negative and enter, arrow down 2 times, 0.02 negative and enter, arrow down 2 times, and last but not least 0.11 and enter. We will then go to our stat worksheet by hitting second 8, arrow down. There is our average return. Our arithmetic average is 4.6%, and our standard deviation is 8.678%. Now that we have this information, we can start to work on, okay, well, which confidence interval are they actually at, right? Are we at the 68, are we at the 95, or are we at the 99.7? So let's start with finding the lower bound on the 68. And that obviously is going to be 4.6% minus 1 standard deviation. And what we find is that the lower bound at the 68 is a negative 4.08%. On the 95, that's going to be 4.6% minus 2 times 8.678%, or more specifically, you can just subtract off another standard deviation from this number, and when we do that, we find that it is 12.755%. That's exactly where they are asking us the probability of us losing money more than that particular number. But let's keep going. If we're looking at the lower bound on the 99.7, again, this would be minus 3 times the standard deviations. And we would find that the lower bound there is 21.433%. In order to answer this question, though, you have to have a good understanding of normal distributions and confidence intervals. Obviously, this is our X bar. And at the 95% confidence interval, we're talking about minus 2 standard deviations and plus 2 standard deviations. All about 95% of the entire distribution should fall within the range of our lower bound and upper bound, which means beyond that, there's 2.5% chance, and below that, there is a 2.5% chance. And since this number right here is that negative 12.755%, the probability, or the answer to this question, is 2.5% probability that the investor is going to lose more than 12.755% in a given year. All right, folks, that concludes this video. Good luck on the homework. Remember to smash that like button and subscribe to the channel. Until next time, goodbye.